All right, let's dive into one of the most practical tools you can have in your mental toolkit, probability. We're going to be using Chapter 3 of OpenStack's Introductory Statistics as our guide to see how the math of chance really helps us make sense of a world that's, well, pretty uncertain.
I mean, seriously, think about it. You do this all the time, right? Whether you're trying to pick the fastest moving line at the grocery store or a doctor is weighing the pros and cons of a certain treatment, we're constantly playing the odds. Probability is just the language we use to make those guesses a little more educated.
So here's what we're going to cover. First, we'll talk about why we even have to guess in the first place. Then, we'll learn the basic language of chance. After that, we'll figure out how events relate to each other, cover 2 super important rules, learn how to visualize the odds, and finally, wrap it all up by talking about why this stuff really matters in your day-to-day life. So, yeah, why do we need to guess? It's simple, really. Life almost never hands us all the information we need right up front. You know, a politician trying to figure out how an election might go. A teacher trying to design the best lesson plan. We all have to make calls based on what's likely to happen. And probability, it gives us a solid framework for doing just that. This quote from the book really just nails it. We're surrounded by uncertainty, and probability is our best tool for cutting through it. It's the thing that transforms a wild shot in the dark into a calculated, intelligent risk. Okay, so if we're going to talk about chance, we all need to be speaking the same language. Think of this next part as learning the absolute basic vocabulary. Once you get these key terms down, I promise everything else is going to start clicking into place. First up is the word experiment. And no, we're not talking about lab coats and bubbling beakers here. In probability, an experiment is just any process where you don't know the exact result ahead of time. The classic example, flipping a coin. You plan it, you do it, but you have no idea if it's going to be heads or tails. That, my friends, is a chance experiment. And every time you do one of those experiments, you get an outcome. So for that coin flip, the outcome is either heads or it's tails. Pretty straightforward. Now, if you make a list of all the possible outcomes, that list is called the sample space. For the coin flip, the sample space is just heads, tails. See? Easy enough, right? And here it is, the star of the show, probability itself. At its core, it's just a number somewhere between 0 and 1. If the probability is 0, it means the event is absolutely impossible, never gonna happen. If it's 1, it's a sure thing, it's certain. And everything else, every maybe, every possibility, every will see, falls somewhere on that line in between. Okay, now this is where things start to get really interesting. This is when we start looking at more than one event at a time. And the big question we have to ask is, are these events connected somehow, or are they completely separate from each other? Trust me, getting this distinction is a huge deal in probability. This slide breaks down the 2 most important ways events can relate. On the left, you've got independent events. That means one of them happening tells you absolutely nothing about the other one. Getting heads on your first coin flip has 0, and I mean 0 impact on what you get on the next flip. Then on the right, you have mutually exclusive events. This means if one happens, the other one can't. A single coin flip can land on heads or tails, but there's no way it can be both. So the bottom line is this: independent events can happen together, mutually exclusive events can't.
All right, so we've got the vocabulary down. Now let's learn a little bit of the grammar. There are 2 basic rules that let us start combining probabilities in really powerful ways. We've got the multiplication rule and the addition rule.
First up is the multiplication rule, and this is your go-to for AND situations. When you want to know the probability of event A happening and event B also happening, you multiply. It's how you'd figure out the odds of drawing an ace from a deck of cards and then drawing a king right after it. Then you've got the addition rule. This one is for your OR situations. What's the probability of event A happening or event B happening? Well, you add their individual probabilities together. But, and this is a big but, you then have to subtract the probability that they both happen. Why? Because you don't want to double count that little bit of overlap where they both occur. So, we've got the words, we've got the rules, but you know, sometimes the best way to really get a handle on probability is to just see it. So let's check out a few tools for visualizing the odds that can take a really confusing problem and make it crystal clear. This is called a contingency table, and it comes right out of our source material. It's just a super neat way to organize data across a couple of different categories, in this case, sex and whether someone is right or left-handed. Tables like this make calculating probabilities a breeze. For example, what's the probability of picking a male from this group? You just look at the totals. There are 52 males out of 100 people, so the probability is 0.52. Simple as that. Next up, the Venn diagram. I'm sure you've seen these before. They are absolutely perfect for visualizing those and or relationships we just talked about. That little overlapping part in the middle, that's the and. The total area of both circles put together, that's the or. It makes it so easy to see.
And for events that happen one after another in stages, you can't beat a tree diagram. Each branch of the tree shows a possible outcome, and you label it with its probability. If you want to find the odds of a whole sequence of events happening, you just follow the path along the branches and multiply the numbers as you go. It's a fantastic way to map out all the possibilities.
So, we've gone through definitions, we've covered rules, we've looked at diagrams, but let's bring it all home. Why does any of this stuff actually matter when you're not in a statistics class?
Here's the most important thing I want you to walk away with. Probability isn't just about math problems on a test. It is a fundamental toolkit for thinking. It helps you go from saying, I have a gut feeling about this, to, okay, I can actually put a number on the uncertainty here. It gives you a structured way to weigh risks, to evaluate your choices, and to make better, smarter decisions in your job, with your health, in your everyday life. And that's our look at the basics of probability. You now have the language and the core rules to start looking at the world in a slightly different, maybe slightly clearer way. So I'll just leave you with this question. Now that you've got the tools, what odds will you start calculating today? Thanks for tuning in.